Hey guys, what's up? Eddie Yahoo here with KissAnalog.com. Guys, you spend a lot of money on solar panels, a bunch of batteries, and then you need an MPPT like that Redodo right there to charge your batteries. But how well is it going to track the power usage that it can pull off the panels? Solar panels can get loaded down if you try to pull too much power off of them, so they come up with the maximum power point tracking, MPPT. So instead of just a regular old DC-DC charger, these guys can track the panel and not load it down too much. You could set up a regular DC-DC converter at some maximum power on a maximum, a bright sunny day, but then, or somewhere in between. And it would work, and it would work pretty well, but it wouldn't give you the maximum power you could pull off your panels. So you buy all these panels and you got to get all these batteries, but you're not using them to the best way you could, right? The most efficient way. So MPPTs come along. Well, then they came up with a couple of standards. All right, guys, so there's the Euro standard, the EN 50530. This guy has it on there as one of the ways to test. There's another one called the SANDIA. SANDIA is a mountain range in New Mexico where there's a lab that's been there for a long time. And they do some things that are classified. And so you don't usually see standards come out of them, but they came out with a standard way of testing. And what it is they just want to see how well these guys track the the solar panel, whatever solar panel you happen to put on there. And I've kind of shown a couple videos of how well this guy seems to do. So something I want to explain is that's a static thing. I'll put up a curve, say 200 watt curve, and you'll see the voltage across the bottom, the current on the vertical axis, and there's a red curve. It kind of ramps up and then it drops off pretty fast. So the current comes across and the voltage builds up, so the power goes up. But at a certain point, you're pulling so much power from the panel that it collapses, okay? So then you back off how much power you're pulling until it goes back up that curve and goes back this way, and then it goes back and forth until it finds that maximum point, okay? That's the idea. And then if a cloud comes over, if it slowly changes through the day, that's easy to track. That's easier to track. But if a big cloud comes over and changes things, then you want to see how fast this guy can react to that. So there's some curves, and they don't react super. I mean, the testing's not set up to change things really fast, and it seems like this guy changes pretty quick. But here we're going to do some static testing, okay? And I'm going to go from 200 watts down to 100 watts, and then I think we'll go back up to something higher, okay? So let's come over here. Let's show you the curves. By the way, you can use a meter like this, plug into your solar panels, and you can see what numbers that your panel is actually giving given the sunlight that it's in. So that's pretty cool. So you can test your panels. If you're picking up some used panels or comparing panels, you can have a meter like this and compare how well your panels are working. But to compare how well your charger is working, you need a solar array simulator like this Itech. All right, so that's what we're going to test. We're testing this with the Itech simulation tool there, and we're going to charge this Cyclone Bat. Okay, thank you, Cyclone Bat, for sending this out for free. Redodo, Itech, thanks guys. Thanks for sending these things out. And also Zaboo for sending out this. This thing's pretty cool. So, all right, guys, let's come over here and test this Redodo and see how the Itech works. Okay, guys, I have this Cycle N Bat, and it has the low temperature protection. It's a little mini, 100 amp hour, pretty sweet. And this is one with the handles come up, so easy to carry. Man, it's very compact. All right, guys, so we're going to charge it the MPPT, and it's expecting a solar panel, right? So right now it's saying the battery's 13.4 volts, okay? So we come up here to the Itech, which if you've seen the other videos, you've seen this already. But in this case, we're going to use the EN 530. So EN 50530. This is the test standard, okay? And I put in for a typical solar panel, like my SunPower solar panel, it's 36 volts. The maximum power comes out 36 volts. That's a VMP. And it's a 200 watt panel. So that's the PMP, okay? And then it says TF is kind of material. So we're going to go with that. We could go to OS, different kinds of material, okay, between CSI and TF. So we're going to say TF. And then, then we say download. And then after we plug all that in, all we do is turn it on. And starts off at 0, so that's open circuit. And then it checks for the highest voltage, 50 volts. Then it starts adding a little current. It comes up the ramp. We're showing the power. And then the power's dropping off here. And it goes up. It's lowering the voltage. It says, okay, that's not maximum power. So it's going to turn around, go back. Oh, and it knew where it was. So it went right back to it. And then it kind of hovers back and forth. So look at that. I punched in 200 watts. It's finding 200 watts. So it's simulating a solar panel. Okay. 35 volts, 5.5 amps it's putting out. So let's come down here. And we got 13.7 on the battery. Okay. Solar coming in. Yeah. 36.2 volts or whatever. It's bouncing around. But that's what's coming in from the solar panel. That's what it thinks is the solar panel. So we're testing these MPPTs with this solar power simulator, right? So we come back down here, 0 watt hours. It has to charge and discharge 3 times to figure things out. Here's the amps. So, and I got to look at that code for 15. And then E00 means error 00, no errors. It's 25C. And it's kind of thinks there's 112 watt hours. So that's how much it's charged and discharged at this point. So that's not accurate until it's gone through a cycle or 2. But here, 13.5 amps is what this converter is converting that 35 volts, 5.6 coming in, but it's putting out 13 volts, and that comes out to about 13.5 amps. So really cool. And it thinks it's 100%. So 13.8. So maybe it is topped off. I don't know. But right here, we're still charging 200 watts. Okay. So still charging. And so I can fully charge the battery. Then I can discharge it, go through a few cycles. And then the MPPT will, calculate all the watt hours and all that kind of stuff. But yeah, this is this Itech in action, testing the EN 50530 curve. All right, now I have the SANDIA regulation curve up, okay? Not the EN anymore. Now we're at SANDIA. So same thing, 36 volts, 200 watts, okay? Let's go ahead and turn it on. And let's watch it. It's calculating the max voltage. Went a little higher, 54 volts. Okay, now it's going to start adding current. And the power curve is this red one. So it's going to start going down on power. And it's going to like, oops, I missed the maximum power. I'm putting out 6.8 amps, but my voltage is low. So it goes back to find the maximum power. So look at that, 212 watts this time. So with the SANDIA, it's like, oh no, I can get 212 watts out of this panel. So let's go back down here, 13.8 volts on the battery, 38.4 volts coming in. That's from our solar panel simulator. Okay. 0 watt hours, like I say, it has to calculate all this stuff. It counts current, Coulomb counter, they call it. And then it figures all this stuff out. 121 watt hours, it thinks. But here we go, 14.4 amps. So at the SANDIA, we're getting 212 watts out of this panel. That's what it thinks. And the MPPT says, well, with the SANDIA curve, I can get 14.4 amps with a 200 watt panel at 36 volts. So that's what it thinks with that curve. Okay, that's pretty cool, huh? Just want to show you this. Hey guys, I want to give 2 big thumbs up to my YouTube members and my Patreons, and Danny for being a team member. Really appreciate that. You become a member, either Patreon or YouTube, for as little as $1 a month. You can support your channel for free just by subscribing, liking the video. So thanks, appreciate that, guys. Like to grow the channel this year, make some strides, get 40K by the end of the year. That'd be awesome. I think about 75% or more of viewers are not subscribed, so we could get there. Just hit that subscribe button. Oh, by the way, if you think you're subscribed, just check. If it says subscribe, for some reason YouTube unsubscribed you, so I'd appreciate you hitting that button again. Guys, this is a pretty cool device, right? This Itech solar array simulator. That's pretty neat. Now, I've tested the 100 watt. Well, we started off at 200, then I went down to 100 watt, and then I decided to go to 400 watts. And at 100 watts, the efficiency from the Redodo, what it was getting from the solar panel and charging the battery was, I mean, there's some error in math because it was right at close to 100%. So it's probably got to be in the high 90s though. And that was at 100 watts, guys. So then at 200 watts, it was about 95%, which is still really good. Now we're going from, 40 volts or whatever, the SunPower solar panel that I set up to have this simulate, it's around 40 volts. So it's dropping down to 12. In my buddy's cabin, the remote cabin up in the mountains, his system's 24 volts. So that Redodo can be set up to do 24 volts. I imagine it'd be more efficient there because, it's dropping less voltage, right? It's not stepping the voltage down as much. So, yeah, it should be a little more efficient. Anyway, still 95% is really good. Then at 400 watts, we dropped down to about 91%. So, now that was putting out about 25.7 amps into the battery. His system is running, when he has full sun, he's getting about the same amount of current into 24 volts, instead of a 12 volt and 24 volts. So yeah, it'd really be interesting to calculate his efficiencies. I think I did once when I was up there, and I don't remember what it was, but next time I go up there, I'm going to have to take some numbers on efficiency. I want to see, it's hard to compare one MPPT to another because there's not a lot of those efficiency numbers out there. But that's what's really important, is how well can this guy track this, and then how efficient is it at charging batteries. Now, as far as tracking, it took about 25 seconds from, like, if you had the blankets covering the panel and you take it off, it would look for the open circuit. So it's not drawing any current in the beginning, and it's looking for the high voltage, because the voltage will float to a high level when there's no current. So it looks for that, it finds that point, and then it goes up the curve, starts pulling current where it's starting to pull more and more power, and then it starts to drop off a little bit again, and then it goes back, and then it finds that point and it stays there, hovers on it really well. If I go from, say, 400 to 200 or 100, if I bounce between them, it locks in within, the longest time it took was probably a couple, 2 or 3 seconds when I went from 1 to 400 or 4 to 1. But I think it was 1 to 4s took the long. The other ones took less time, about half as much. They were almost instant. And then they just slightly move around a little bit more until they locked in. But going from 1 to 4, it would jump up, and then it would take the steps between were a little bit bigger, but within 2 or 3 seconds it was locked in. So that's pretty fast. If a cloud came over and solar energy dropped, so if it had to do that maximum power tracking, it would track it very quick. It's just when it starts from 0 is when it seems like it has to lock in that VOC, that open circuit voltage first, and then it tracks from there. So there you go. Seems like it tracks very fast, and it's pretty efficient. So what do you guys think? If you guys got some experience, some efficiency numbers you can share with other inverters or other MPPTs, let us know. All right. Hey, thanks for watching. We'll see you next time.